5? Okay, for an isosceles triangle, doesn't matter if it's upside down or if it's sideways or if it's right side up. Isosceles, the definition is actually at least two sides the same. So if you have an equilateral triangle, you could call it isosceles, but this best name is equilateral. So there's three sides to a triangle. If it's isosceles, the two that are equal are called the legs. And the third side is called the base. So the base we usually think of as the bottom, but it doesn't have to be. So the base angles are the two angles that are hooked to the base. And if it's isosceles, if two sides are the same, two angles got to be the same. All right? Now that works both ways. If you saw a triangle like this, where those two were marked that they're equal, because the angles are equal, that means two sides are equal, and they would be this side and this side, the sides opposite those angles. Okay, so it works both ways. If the two sides are equal, the angles are, and if the two angles are equal, the sides are equal.
Okay.
The vertex angle is the angle that's the two legs hooked to. So opposite the base is considered the vertex angle. So that's the theorems right here. So finding degrees of triangles. In this, there's 1, 2, 3, 4, 5, 6 angles in there. We're only given one, but you could find every other single angle. Since this little triangle right here is an isosceles, I know that this is 70 right there. So I could figure out that one. They got to add up to 180. 70 is 140, which means that would be 40. Since this is 70 right here, I can find the angle next to it, right?
Yeah.
What would it be?
That would be 110.
110. And if you look at this triangle, it's an isosceles triangle. So since these two sides are equal, these two angles are equal. And since this is 110, that means there's 70 degrees left over, right?
Split them.
And then you gotta, since they're equal, you gotta split them in half, so each of these would be 35 degrees. So this one, there's a little more work to do,
Oh, geez.
but anytime you see an equilateral triangle, all three sides are the same, so that means all three angles are the same. So what are the angles always gonna be in equilateral triangles? 60. 60, 60, 60.
Because they have to add up to 180.
Right. So if this is 60 right here, these two angles are 70 and 60 adds up to 130. So this angle right there would have to be 50, right? Because we gotta add 70 and 60 and 50, gotta make a 180. And since this is an isosceles triangle, here's the two sides are the same, so these two angles are the same. And since this is 50, that leaves 130 degrees left over. And since these two are equal, you just cut that in half. So y would be 65. And the same thing over here. Here, this is an equilateral triangle. This is 70, which means this one is also 70. So that's 70 and 70 is 140. Subtract that off of 180, 40 degrees. So there's a little bit of work on some of these. But remember to spot the equilateral triangles right away. They like to throw a lot of them in there. Here,
I have a question.
yes,
Are equilateral triangles, are they always equiangular?
yes. Equilateral is always
So
equiangular.
the angle's always equal?
Yep.
But then not the third one usually because you can't have it, right?
No, isosceles triangles have
Yeah.
the same angle.
Isosceles
so that
are
last
two.
one we did with isosceles.
Yep, this was isosceles and that was isosceles. If a triangle is equilateral, since three sides are the same, the three angles are the same, and it works the other way too. If they're equiangular, that means all three sides are the same. So equilateral, equiangular are the same. This one, we've got an isosceles triangle. So that means if this is 75, so is that one. So 5x has to equal 75 because we're trying to find x and y. So all you got to do is divide by 5, and that is 15, right? 10, 25. So since these two are both 75, that makes 150 degrees. That means this angle has to be 30. So 3y equals 30. Divide by 3, and that's 10. Now we get into this section. Actually had the HL, but we learned it last week. Remember, that only works on right triangles. If the hypotenuses are equal and the legs are equal, that means the triangles are equal because HL. So in this one here, they've got a volleyball stanchion. And now they don't have those cords like they used to, but they used to have wires coming down connected to the floor to hold it up. So it tells us the volleyball net is perpendicular to the plane, so this is a 90 right there. It's got a shared side, right? This forms three right triangles. And it tells you that each of the lines running from the top of the pole uses the same length of rope. So that means this equals that equals that. These lengths are all the same. So what would make all three of those triangles congruent? What? No, because we don't know these bottoms.
It's
SSA, but that's not a
HL. So it's not.
hypotenuse leg. The wires running down are the hypotenuses, and then the pole going up is the leg, and they're all at perpendicular, so HL would make them all equal to each other. So if we had to prove this triangle is congruent, they give us that RV equals ST. So this whole side equals this whole side. And they give us that they're right angles. So what would make these two triangles RVT congruent to STE?
Wouldn't it be?
If I drew it separate,
Because they have a shared.
right, they got a shared side. If you separated them, they told us this equals that, they told us these are 90s, and this bottom piece right here is a shared side. So when they're drawn like that, it's easier to see. When they're together, it's a little harder. But the hypotenuses are equal, and it's got a shared leg, so it would be HL. So,
Oh, yeah.
We not have an assignment?
when you do your assignment,
No.
a lot of it is
Say no one look at me.
finding the unknown measure. Shh. Like here, there's isosceles triangles. On the next page, they've got composite figures. So you've gotta find the X and Y in each. But the other ones, like these, 11 through 13, and 5 through 7, it's just like we've done before. Determine whether enough information is to prove that, or given to prove the triangles are congruent. Explain your answer. Everyone know what to put to explain your answer? HL, HSA, SAS. So it's just like the other ones we've done before. Just give the reason that makes them congruent. If it's not, you just put no. That's what you do 5 through 7 and 11 through 16.
5 through 7.